Ground fault circuit interrupter. You may have seen these in your kitchen or bathroom, especially if your power outlets have been changed in the last couple of decades. There are circuit breakers in your house's circuit breaker box, which is typically located in the basement or out of the way area. They will open up a circuit if it is somehow shorted, which would put electricity through your body, which is not good, or start a fire in the walls. But they don't act quickly enough to stop the current flow to provide maximum safety. The ground fault circuit interrupters were created to provide better safety for electrical outlets near sources of water, such as your kitchen or bathroom faucets, and are now required by electrical code for all new installations. What they do is detect a possible short circuit and act much more quickly than a circuit breaker to stop the current flow through a person or the wire insulation, which would start fires. They take advantage of electromagnetic induction to perform their life-saving role. Here's a simplified schematic of the GFCI. And now we're crossing the border from physics over into actual engineering and electrical installations. So this may look really horrible and confusing, so you may have to pause it, read it, and come back to the explanation. But this is pretty cool stuff. So let's look over here. Here's your two-wire circuit. This is coming from the electric company. You have your line, your hot line here, and your neutral. This is coming from the electric company to your outlets. And down here, here's your outlet. This is a schematic of where you would plug your plug-in, your two-prong plug, where you would plug in your hairdryer or electric shaver or whatever. Over here we have a test switch to make sure everything operates right. We have these two wires, the hot wire and the neutral, going through a metal core, a coil. This is going to be connected to a secondary circuit. We've shown all this before, but now we're just showing it with a real live piece of electrical equipment. We have wires wrapped around this coil, and they're going to sense a current change in the primary circuit. They are connected up to an electromechanical switch that when current flows to it, if there is a current induced in these wires, think Faraday's law, it will then open up this primary circuit right at the source here, right near your plug, to cut the current immediately. So if there were a short, that will prevent the electricity from going to you, which is not a good thing. And here's the legal information for where we got the picture from. In case the last page was too confusing, we're going to do it again a little differently. L and N, these guys here. They're the household wires. Those are running through your wall, and they provide a supply and a return path for the current from the power utility. Number one here, this is the electromechanical device that will open the switches when a current flows in the secondary circuit loop to the device. So here's the power coming from the utility. It would come through here, and here's right over here would be where you're plugging in your hairdryer. And this switch here pops open when you have a short circuit. Let's see. Number two, here's your secondary loop. This is detecting a change in current, and by Faraday's law will generate an EMF and a secondary current that will tell this switch to open. Number three, that's the metallic core, the iron core, that contains and amplifies the magnetic field due to the household wires, and four is a test switch. So let's go back to this guy here. A wire, a change in current, will induce what? It will induce an EMF in a wire that's nearby, right? This changing magnetic field, magnetic flux, would induce a current here. That's how we started this unit on Faraday's law, and now we're showing a practical application. Now let's see how this thing operates. And we'll do it by asking you a question. If a current is flowing normally to a hairdryer, here's the current coming through the hot wire, comes down to your hairdryer. I'm not even going to try and draw one, I'll just hairdryer. So the current's flowing here, flows back, right, because we need a complete path for a circuit. So if current is flowing normally, will a magnetic field be created in the core, here, this 3, that would then generate a current in the secondary loop 2? Think about the direction of the magnetic field about a current-carrying wire before you answer, and then go to the next slide when you're ready. No, an equal amount of current is flowing through the L wire as is flowing through the N wire if everything is working properly. So their magnetic fields will be in opposite directions and they will cancel out. One would be clockwise, the other is counterclockwise. So let's just put the hairdryer down here again, the box hairdryer. So that's the normal condition. However, what if somehow this wire gets cut and it just touches the outside of the hairdryer with your touching, or if you splash a lot of water in here, let's say your finger's very damp, it gets near here, and then the current starts trying to flow through you, or it was starting to flow through the outside of the hairdryer, which of course still gets back to you, and then that goes to ground. What happens then? The situation that we have now is current is flowing this way, and it was trying to get to the hairdryer, but maybe it got shorted to the outside of it, or water was splashed on it, and current is now trying to flow out here. So no current is flowing back through the N wire. What's going to happen to the magnetic field within the core 3? So let's draw our hairdryer in again. Here's our hairdryer. And we still have current flowing from the L wire, but then there is no current through the N wire. So what happens is there's still a magnetic field being generated by L. There is no magnetic field being generated by N. So this loop now sees a changing magnetic flux. The magnetic field went from a 0, right, because the two of them balanced off each other. They were opposite in opposite directions. And now I have a value for the magnetic field. So a current is now induced in the secondary side, first the EMF and then the current. This current flows through the electromechanical device number 1 that opens up this switch, current stops flowing, and that will protect both your life and property. Most important, of course, right there.